Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're going to be looking at adding and subtracting surds. So before we do that, I've got a quick recap for you. Please simplify question A and B by collecting like terms. Pause the video, have a go with this yourself. Okay, so question A, we've got 13a minus 18a. Because they are like terms, I'm just going to do 13 minus 18, which is negative 5. So we've got minus 5a. Question B, minus 19x squared is a like term with 18x squared. So minus 19 plus 18 is minus 1. So we've got negative x squared plus 7y. Now, adding and subtracting surds is very similar to collecting like terms. Okay, it's very similar to adding and subtracting like terms. So for example, we can see here we've got 5 root 2 plus 7 root 2 is equal to 12 root 2, because 5 plus 7 is 12. And we can see here 8 root 3 plus 4 root 5 minus 19 root 3. Well, 8 minus 19 is minus 11, so we get minus 11 root 3 plus the 4 root 5. Okay, so we can see it's very similar because imagine it said 5x plus 7x. Well, that's 12x. Instead of saying x, we're using root 2. Okay. And here we've got 8 root 3 plus 4 root 5 minus 19 root 3. Pretend it says 8x plus 4y because they're different, minus 19x because they're the same. Root 3 is the same. So here we can see that's equal to negative 11x plus 4y. It's just that instead of x, I'm using root 3. So x root 3. Instead of y, I'm using root 5. Y root 5. Okay, so let's have a look at each of these. Simplify each of the following. 2 root 5 plus 6 root 5. Start off nice and easy. They are like terms. It's like saying 2x plus 6x is 8x. It's just not x, it's root 5. So 8 root 5. Question B, root 3 minus 5 root 3. We'll pretend it says x minus 5x. That's minus 4x, but instead of x, we're saying root 3. So minus 4 root 3. Question C, 3 root 7 plus 2 root 7 is 5 root 7, and we still have to write out minus root 6. So have a go with question A and B. Alright, so this one is just 6 root 3. And question B, 4 root 6 minus 3 root 6 is just root 6. 3 root 2 plus 2 root 2 is 5 root 2. Right, but sometimes we need to actually simplify the surds before we can collect like terms. So we can see here, right? Question A, 5 root 2 minus root 8. You might think, oh, we can't do anything with that. They're not like terms. But we can actually do something with this. This root 8 can be simplified. So we've got 5 root 2 minus, well, we can split this root 8 into root 4 root 2. Right? And the square root of 4 is just 2. So I might just, instead of writing this, I'm just going to write 2 root 2. Okay, because the square root of 4 is 2. And now we can see, oh, like terms. 5x minus 2x is 3x. It's just not x, it's root 2. In question B here, we've got 2 root 5 minus 3 root 20 plus 6 root 45. You might be tempted to think, oh, we can't do anything with this. There's no like terms, but we can simplify 20 and 45. Okay, so we've got 2 root 5 minus 3. what can I do with that root 20? What can I split it into where one of them is a square number? 4 and 5. Okay, 4 times 5 is 20. So 3 root 4 root 5 plus 6. What can I split this 45 into where one of them is a square number? 9 and 5. I can square root 9. So 6 root 9 root 5. So now we can see, oh, alright. Square root of 4 is 2. Square root of 9 is 3. So we can see we've got 2 root 5. 3 times 2 is 6. So we've got minus 6 root 5. 6 times 3 is 18. So we've got 18 root 5. Oh, and now they are all like terms. They are all in terms of root 5. So it's like saying 2x minus 6x plus 18x. So that's minus 4 plus 18 is 14x. It's just not x, it's root 5. So why don't you pause the video, have a go with C and D by yourself, and when you're ready to check your answer, keep playing the video. Alright, so I'm having a look at C. I can see 192 and 48. I might start with that 48 because I can think of 16 and 3. 16 times 3 is 48. So I know that the square root of 16 is 4. It's just like saying 4 root 3. Okay, 16 times 3 is 48. Just like the square root of 16 is 4. So because this one's 3, and I've got 192, I'm just going to use my calculator and see if I can divide 192 by 3. I can, I get 64, which is a square number, which is perfect. I can square root 64, and the square root of 64 is 8. So we've got 8 root 3. And now we can see, perfect. These are like terms. 8x minus 4x is 4x. It's just root 3 is not x. Okay, question D here. We've got 12 root 5 minus root 80 plus 3 root 45. I'm thinking to myself, this is already 5, which is pretty small. I can't split the 5 already. So maybe I can make each of these in terms of 5. Well, 80 divided by 5 is 16. Perfect. That's a square number. I can square root that. So we've got 12 root 5 minus, well, this is root 16 times root 5, but the square root of 16 is 4, so it's technically 4 root 5 plus 3 times, well, root 45 is the same as root 9 times root 5, and square root of 9 is 3, so 3 times 3 root 5. Alright, so technically we've got 12 root 5 minus 4 root 5 plus 9 root 5. Okay, 3 times 3, 9. So we've done it. We've got our like terms. They're all in terms of root 5. 12 minus 4 is 8 plus 9 is 17. So the answer is 17 root 5. Alright, what about when we've got fractions? Alright, simplify the following. Whenever we add and subtract fractions, we need a common denominator. Right, so here, they don't have a common denominator. So I'm going to make the common denominator 45 by timesing that by 5. So I times this by 5. Times this by 9. So I times this one by 9. So we can see 4 times root 7 times 5 is technically 20 root 7 over 45. And 3 times 9 is 27 root 7 over 45. So now I've got my common denominator. And we've got 20 root 7 minus 27 root 7. Oh, they're like terms. Root 7 and root 7 is like 20x minus 27x, which is minus 7x. But it's not x, it's root 7. So the answer is minus 7 root 7 all over 45. In question B, we've got a fraction here. But we can't add or subtract. We need a common denominator for us to do that. So I need this to be over. That's currently over 1. This is currently over 1. I want a common denominator, so I can times this by 3 to make it over 3. So times that by 3. Same with this. And so we get 33 minus 2 root 13 plus 3 root 13 all over 3. Okay, they now all have the common denominator of 3. And do we have any like terms here? We do. That's a like term with this. So we can collect like terms. Minus 2 plus 3 is 1. So we get plus 1 log of root 13 all over 3. Alright, let's have a look at C and D. Maybe I'll get you to pause the video, have a go with this, and then I'll just reveal the answers. Alright, so here's the answers. So for question C, we need a common denominator of 12, so multiplying the entire left-hand fraction by 3, the top and bottom, and the right fraction, both top and bottom, by 4. So we get 9 root 5 minus 4 root 20. Now this root 20 we can split into root 4 root 5. And 4 times root 4 is 2, so 4 times 2 is 8, and that's how we get that 8. Okay, so 8 root 5. 9 root 5 minus 8 root 5 is just root 5 over 12. Question D. We need a common denominator of 4. So really I only need to multiply the right fraction by 2 for both the top and bottom. So root 98 minus 10 root 2 all over 4. Now this 98 I can split into 49 times 2. And the square root of 49 is 7. So now we've got like terms. 7 root 2 minus 10 root 2 is negative 3 root 2 all over 4. Alright, let's have a look at some challenge questions. First one. Write root 44 plus root 275 in the form k root 11, where k is an integer. So we've got root 11 here. So we should be thinking about, oh, how can I write this as something times root 11? Well, this is technically root 4 times root 11. What about this one? 275 divided by 11 is 25. Root 25, root 11. So, square root of 4 is 2. Square root of 25 is 5. 2 plus 5 is 7. So that's it. We have written it in this form. K is just 7. Okay, so if a question asks you, find k, k is 7. Question 2. Have a go with this one. Alright, so let's check our answers. Root 50 is the same as root 25 root 2. And root 32 is the same as root 16 root 2. Okay, 16 times 2. Square root of 25 is 5. Square root of 16 is 4. 5 plus 4 is 9. Question 3. Root 75 plus root 12. Write it in the form a root b, where a and b are integers. So 75, we know that's root 25 times root 3. 12 is root 4 times root 3. Square root of 25 is 5. Square root of 4 is 2. 5 plus 2 is 7. Done. We've written it in this form. A is 7, B is 3. Okay, if the question asked. Question 4. 2 root x minus root y equals 0. Find a value of x and a value for y so that root x and root y are surds. So let's have a go with this one. So I might move the root y to the other side of the fraction, of the equal sign, sorry. So we've got 2 root x is equal to root y. I might now square both sides. If I were to square both sides, then I'm going to get 4x because the root and the square cancel each other out. So I'm going to get 4x is equal to root y squared is just y. So I can find any, if I were to use any value of x, let's just say x is 3. If x is 3, then y is equal to 4 times 3. It's just 12. Okay, and that's it. Right, if x is 2, then y is 8. Okay. 4 times 2 is 8. If x is 5, y is 20. Okay, so this is find a value of x and a value of y, so it could be anything, to be honest. Alright. For what value of x is root 2 plus root 2 plus root 2 plus root 2 equal to 2 to the power of x? True. So, what we have here is we've got 4 lots of root 2. Okay, so we can see here, we've got 4 lots of root 2. Now this is sort of like saying 2 squared times 2 to the power of half. Right? Remember this, this surd has a power of half. Okay, 2 squared is 4. So the reason why I've done that is I've made it so that they have a base of 2 because we want our answer to have a base of 2. And we know that the index law, when we multiply terms with the same base, we add the powers. So 2 plus half is 2.5 or 5 over 2. And if that's equal to 2 to the power of x, we can just see, well, the bases are the same, the powers have to be the same. So x is equal to 5 over 2. Alright, and I think we've got one last one for this video. If root 48 plus root 108 can be expressed in the form k root 6, where k is a surd, okay, k is a surd, determine the value of k. So we've got root 48 plus root 108. Root 48, I know, is 16 times 3, so we've got root 16 root 3. Now this is root, but maybe we won't use 3. I know we can, but here it says we've got root 6. So let's use that instead. We'll just say it's root 8 root 6, because 8 times 6 is 48. What about that 108? What do I get when I divide 108 by 6? Get 18. Get root 18 root 6. So now I can add these because these are like terms. They're both in terms of root 6. So it's sort of like saying root 8x plus root 18x. So that's going to equal to root 8 plus root 18 lots of root 6. Now let's see if we can simplify that. Okay, let's see if we can simplify this. Root 8 is the same as 2 root 2, because root 4 root 2 is 2 root 2. And root 18 is technically root 9 times root 2, which is 3 root 2. times root 6. Okay, so that simplifies to 5 root 2 root 6. Now, it says here k is a surd. This is k, right? So we can see that k is equal to 5 root 2. Well, if we want to express that as a surd, we need to square that 5 to give us 25. So it's like saying 5 is the square root of 25 times root 2, which is technically root 50. Okay, we can just times them together. So we can say that root 48 plus root 108 is technically equal to root 50 times root 6, because we said that this here, all of the coefficient of root 6 is root 50. Okay, 5 root 2 is root 50. And we can double check our answer. So if we go to our calculator, if we do root 48 plus root 108, we'll get 17.32. If I also do root 50 times root 6, I'll get exactly the same answer. Okay, and we'll look, exactly the same answer. And that's it. So the question says determine the value of k. Okay, so this is our final answer. Okay, find the value of k. Alright, so that's it for this video. We had a look at how to add and subtract surds. Okay, we need them to be like terms. If they're not like terms, we might need to simplify the surds so that we get like terms. We did it with fractions. Okay, and we need a common denominator when we add and subtract fractions. And we looked at some more challenging questions. Okay, where we've got pronumerals that we needed to work out the value of, or write expressions in different forms. Okay, so that's what we looked at in this lesson. If you have any questions, just let me know in the comments down below. If you found the video helpful, please give it a like. And if you would like more content, please subscribe, and I'll see you in the next video. See you.